So before I start changing my data type, I want to check my memory usage before that. So in this case, I want to see the info. So in this case, I'm using my argument memory usage equal to d. That's going to give me the actual memory for my object data type. So in this case, when I run this, you can see that my actual memory is 74 kilobyte. And right now you can see that miles per gallon is float 64, cylinder is end 64, so displacement is float 64, and so on and so forth. Okay, what if you want to see the memory usage of each column? You can do that too. You can say df dot memory usage and type df equal to true. That's your parameter you have to supply. When you run this, that's going to give you the memory usage for each and every column. So for example, right here, weight column is consuming 3184 bytes. Now let's start with the column miles per gallon first. So first thing I do, I check my range. I want to know my minimum and maximum range. So in this case, I print my minimum and also my maximum in this case. So it goes from 9 to 46.6. So let's check our memory usage in bytes for the miles per gallon before I change my data type. So in this case, I'm doing df.memory usage just for miles per gallon. I'm also printing the data type. So in this case, it's consuming 3,184 bytes and it is float 64. Now I change the data type. I'm changing it to float 16. So and that's because my range of values they go from 9.0 to 46.6. In this case, I do not need a high precision here. So in this case, I'm changing my data type from float 64 to float 16. And then I check my memory usage over here. So after I change my data type, you can see that it changed to 796 bytes. So before changing the data type, it was 3184. Now it's 796. So what is the percentage reduction? I do the calculation over here and it comes out to be 75% reduction in your memory usage for that particular column. I want to see the info now. I want to know what is the total memory usage now. So in this case, when I run this command, this is a different one. In this case, you can see that at the end, it shows 71.6 kilobyte for the whole data frame. Now let's focus our attention on cylinders now. It seems like this particular column cylinder has a finite numbers and it seems like it is categorical in nature. So let's perform value count on cylinder. So in this case, when I do the value counts, it actually prints out the number of four cylinder. There are 204 cars. For eight cylinder, there are total 103 cars, and for six cylinder, there's 84 cars, and same thing for your three and five right here. So I want to see the memory usage in bytes for the cylinder before I change my data type. I also want to see, I want to print out my data type. So in this case, you can see that 3184 bytes. That's how much memory this particular cylinder column is consuming, and its the data type is N64. And now I change my data type based on my values, and I know my minimum value is 3 and maximum value is 8 for this particular column. So I'm going to change my data type from Int64 to uint8 based on the cheat sheet that I just showed you a minute ago. Now, do not change this to category, especially if you want to use for machine learning model later on. You want to always want to keep it numeric. So in this case, when I run this and then I check my memory usage after this, and it comes out to be 398. Well, how much reduction is there? Well, it's 3184, which is this number. 3184 minus 398 divided by 3184, the answer comes out to be approximately 87%. So there is an 87% reduction in that column by changing the data type. Now I want to see my memory usage for the whole data frame. So when I run this, you can see that memory usage comes out to be 68.9. So initially we start with 74 and now it is 68.9. All right. And now let's do the displacement, the column displacement. So in this case, first I'm doing my range check. I want to know my minimum and maximum value. Same thing I did before. So minimum is 68 and maximum is 455. I want to check my memory usage in bytes for displacement before I change the data type. So in this case, my memory usage is 3184 bytes. That comes from here. And I also want to see my data type in this case. It comes out to be float 64. Now for displacement, my range of values are from 68 to 455. And I also know that all values are whole numbers. So in this case, I will use int. And based on the cheat sheet, I used int 16 in this case. So after I change my data type to int 16, I print the memory usage for that particular column, and the answer comes out to be 796 bytes. Now I want to know my how much is the total memory of my data frame after this. So now when I run this, it comes out to be 66.6 kilobyte. So in this case, my initial memory was 74 kilobyte. Now it's 66.6 kilobyte. And you can also see, by the way, your miles per gallon now has changed to float 16. Your cylinder has changed to uints 8. Your displacement to this. Your horsepower. Well, horsepower has not changed yet, but you can see that these three are changed now. And then the horsepower. So in this case, first thing I do, perform my range check. I want to know my minimum and I want to know the maximum. It prints out the minimum and maximum. Then I want to see the memory consumption by that column. In this case, it's 3184. I also want to see my data type for my horsepower. It is right now float 64. So for this particular column, the range of values are from 46 to 230. Also, I know from the domain knowledge that these values, they need to be whole number. They'll always be a whole number. So in this case, I'm going to change it to uint 8 based on the cheat sheet. So after that, what I do, I check my memory consumption after this, after changing the data type, and you can see that the memory consumption now is 398 bytes. Then I want to know, this is only for the 398 bytes for that one column. I want to know my memory consumption now for the whole data frame. So in this case, memory consumption for the whole data frame is 63.9 kilobytes. And you can see that your horsepower now has changed to uint 8. And same thing with the rest of the one on the top right here. And now you do the same thing with weight. First, you find your minimum and maximum. This gives you your minimum and maximum. You check your memory in bytes before changing your data type. So in this case, it comes out with 3184. Now for the weight, the range of values are from here to here. These are my numbers. So in this case, I'm going to change it to int 16. And my now this time I'm checking my memory usage in bytes after changing the data type. In this case, comes out to be 796 bytes. Then I want to print the memory usage again, and this time it comes out to be 61.5. You can see that each time I'm changing the data type, my memory consumption is going down. So now the weight is int 16. Then do the same thing for acceleration. Check your minimum and maximum value. Print out your memory consumption before changing the data type. In this case, that particular column is consuming this amount of memory. Then for the acceleration for this particular column, my minimum values are 8 and maximum value is 24.8. So I'm going to change my data type to float 16 because I do not need high precision in this case. So then I can check my memory consumption for that column. It comes out to be this right here. And then I will print out my memory total memory consumption by the whole data frame. Comes out to be 59.2. And you can see that now your column acceleration is using float 16. And then we do the same thing for model year. I print out my minimum value, I print out the maximum value. These are my minimum and maximum value. I want to know my memory usage before I change in data type. In this case, same thing. Then I change my data type to int 8 because my minimum value is from 70 to 82. These are my range. That's it. So I'm going to use to int 8 in this case. Then I print out my memory consumption for that particular column, comes out to be this number. Then I want to know what is the total memory consumption, like what is it now. So in this particular instance, you can see that total memory consumption is 56.5 bytes. And in this case, model year, now you can see that it has changed to int 8. And now I'm going to fix data type for the column origin. Presently, it is object. So first I want to check my value counts for my origin. So in this case, when I print out the value count, that tells me for USA, there are 249 records. For the Japan, there are 79 records. For the Europe, there is 70 records. So this seems to be a good candidate for category. So in this case, I'm checking my memory consumption before changing data type. In this case, look at that, 24,248 bytes. Then I changed my data type to category. So it went from object to category. And then I check my memory consumption now. In this case, look at that. Now, this particular column is consuming only 691 bytes. Then I want to check my data frame memory consumption. And look at that. Now, your data frame actually went to 33.5. So you can see that your origin now has changed to category. So how much is there saving? Well, 74 minus 33.5 is 74. Divided by 74, the answer comes out to be 54. So there is a 54% reduction in your memory so far. So on a side note, I can automate this process where I'm converting all my object columns to category. And I can actually use an algorithm. What it basically does is that it's going to check the number of unique values. If my number of unique values in that column is less than 50% of my total values, it is going to change that to category. So I can actually implement that logic very easily. Just first you find all your object columns. So this particular right here is going to print out all your object columns. Then you iterate through every single object column. You find the number of unique values from that object column, and also you find the total number of values. Then you find if your percentage of your number of unique values is less than 50%, then you convert that to the category in this case. So this is the one I'm using to convert to category. Otherwise, do not. And then finally, the name right here. So first I want to know my value comes from my name. In this case, it tells me Ford Pinto is repeated 6 times, Toyota Corolla is repeated 5 times, and likewise, same thing down. So in this particular instance, I really don't need this column. So I'm just dropping this column completely. Then I check my memory usage. So it should come no surprise to you that there will be a big reduction in your memory usage now. So now your memory usage is 5.1 kilobytes. So let's print our sample now. I want to see my first 10 samples. So these are my first 10 samples. You can see the MPG cylinders, displacement, horsepower. It prints out the first 10 samples. And in this particular instance, there is no Boolean data type, so we don't have to work on this. And we are done now. So let's check how much memory is saved. So when you do 74 minus 5.1 divided by 74, the answer comes out to be 93%. So there is a 93% reduction in your memory. And now I want to save my data frame with the data types. So the first option that may come to your mind the wrong way would be save it to a CSV file, a test.csv. Well, this is a wrong option, and that's because this actually saves in a CSV file. CSV does not remember your data type. So the right way would be you want to save it in a pickle format. So what it does, it preserves the data structure, your data type, and so on and so forth. So this way you can actually load your file later on and don't have to do this process all over again. So in this case, I'm changing it to pickle file. Sorry, I'm saving it to pickle file. And this is my pickle file, data mpg clean.pkl. So after save it, now in the future, if you have to go forward, let's say you want to perform univariate analysis, you want to perform bivariate or any type of analysis, you can actually read this pickle file right here, the one that you saved over here, and you can perform all your analysis on this. And you can see that in this case, I read the pickle file and then I print the info right here. When I print the info, you can see that your MPG now is float 16, cylinder is uint 8, uint 16, uint 8. You see that everything now it retained that. So that's one of the advantage of saving in a pickle file is that it retains, it remembers the data type. And also your memory consumption now is only 5 kilobyte.